This firm enjoys the monopoly of formal Macintoshes in country X. The demand for formal Macintoshes is given by the equation P equals 1000 minus 2Q. The total cost per production equation is given by total cost equals 120 plus 4Q.
One must also consider the following components of total cost.
First question will be, what is the equilibrium price of the formal Macintosh market, and how much profit is the company making at the equilibrium level, considering that the firm is a monopoly? First of all, we would have to find total revenue, which is easily found by multiplying P times Q, which gives the equation 1000Q minus 2Q squared. We know that marginal revenue is just the first derivative of total revenue, which gives the equation 1000 minus 4Q. And we can do the same with marginal cost and total cost. So marginal cost is going to be 4. In order to find the equilibrium point, we have to equal MC to MR, which will give a quantity of 249. Plugging this back into the original equation, we're going to get a price of 502 monetary units. Therefore, if we follow this equation, which is total revenue minus total cost, we will find the profit. One day, however, a new disease called the Big Bad Virus was spread around the world, and Mr. Yogo was forced by the government to close Bilu Good Good's retail locations. Now imagine that country X does not have internet. Question 2 will be, what do you predict will happen to Bilu Good Good's demand for labor? Well, clearly, Bilu Good Good's demand for labor will massively decrease or cease to exist.
So after a few months, what actually happened was that the Big Bad Virus became a lot less dangerous, and country X was actually able to reopen. Now, when the time came for Mr. Masayoda to hire workers again, he discovered something very, very interesting. People were not accepting his offers at the original wage level, so the pre-Big Bad Virus level, and they actually required more money for their efforts. So, taking that into consideration, what conclusions can we take regarding the elasticity of labor to Mr. Masayoda's business? So it's quite simple. The supply of labor to Mr. Masayoda's business, Bilu Good Good, will actually become more inelastic, and we can see that clearly on the chart. We have two supply curves plotted. The red one, which is the old supply curve, and the green is the new supply curve. We have the blue curve, which is the demand curve. It's at 5 because demand just stays constant, as we saw in the first assumption. So as we can see, the new supply curve is a lot steeper, which means a lot more inelastic, and that overall means for this particular demand curve, wages are going to have to go up. So Mr. Masayoda will have to increase his wages.
Consider that Bilu Good Good has a constant demand for labor in its retail location, and that the original and new supply curves are given by P equals Q and P equals 2.5Q minus 4. Now, consider that the optimum wage for the factory workers increased by 100%, and that the rent Bilu Good Good pays for its store remains at pre-virus levels. Question 4. What is the new wage level for the retail workers at Bilu Good Good? Now, we consider that the demand is constant at Q equals 5, as shown by question 3. The supply function will be P equals 2.5Q minus 4. We replace our quantity for demand in the supply function to give us 8.5 monetary units. Therefore, the new wage level for the retail workers is going to be 8.5.
Question 5. Taking into the consideration the assumptions mentioned before and the fact that demand for a product has remained constant, calculate the new optimal point of production for Bilu Good Goods formal Macintoshes and the market price. What are the changes to total cost and profit? So the new total cost is now 137.5 plus 8Q based on the previous assumptions. And the marginal cost is just a derivative of total cost, which in this case is 8. Marginal revenue is a derivative of the total revenue, which is 1000 minus 4Q. The profit maximization point is when marginal cost is equal to marginal revenue. So you just make the functions equal to each other. 8 equals 1000 minus 4Q, and Q is then 248. Plugging it back into the demand function, P is equal to 1000 minus 2 times 248 is equal to 504 monetary units at that point. And at that point, profit is equal to total revenue minus total cost, and it ends up being 122,870 monetary units. So in the end, the optimal point of production is that Q equals to 248 and price equal to 504, with a profit for Bilu Good Good of 122,870 monetary units, where profits have decreased and total costs have almost doubled.